Hello everyone, I'm Avinash Sugar. So this is my day two of the video where I'll be teaching basic ML concepts which I learned in the previous day. So machine learning is all about making classifications and making predictions. So there will be having two sets of data, training data and testing data. And training data will be used to train the model and testing data will be used to evaluate the model. So here in ML we have few concepts like cross validation, bias variance, stuff to evaluate the model. So cross validation is nothing but a method through which we can test the model. Like we can if we have a data set of 1,000 records, so we don't know which data will be the best fit to train the model or to evaluate the model. So what we'll be doing is we'll be breaking the data sets into multiple blocks and we'll be doing, we will be making mix and match of multiple data and we'll be giving it to the model and they train it. Then we'll be testing it with the remaining data. Usually, we'll be splitting it into 10 parts where they call it as a tenfold cross validation. There, nine blocks will be used for the training purpose, and the remaining one block will be used for testing purpose to evaluate the model. So, this is about cross validation. And we have something called as confusion matrix. So, confusion matrix is nothing but where we have this matrix kind of structure where we'll be having predicted and actual values. So actual values is nothing but the value which we know for sure that is correct. But our model might have predicted in different. It might say yes sometimes. It might say no sometimes. So this is what this confusion matrix is about. So here we can see that true positive means the model also predicted true and it is actually true. If it's false positive, it means our model predicted it as positive. That is correct, but the actual value is negative. And likewise, if it's like a false negative, it means our model predicted it as true, but it's actually negative. And if it's false negative, true negative means our model also predicted as negative, and actually its value is negative. So this is how a 3 into 3 confusion matrix will look like. So next we will see a sensitivity and specificity. So in sensitivity is nothing but true positive divided by true positive plus false negative. And sensitivity tells us how much the data is accurate, how much the data is correct. And specificity tells us how much the data is incorrect. So based on the use case and scenario, we can decide whether to consider sensitivity or specificity and which should be higher or whether it should be equal. Mm, So that is about sensitivity and specificity. And here, let's take an example of how to calculate sensitivity and specificity. So here sensitivity is nothing but true positive divided by true positive plus false negative. So let's take this example where we will be calculating sensitivity and specificity for troll 2. So here true positive is nothing but a model predicting it as right and which is actually right. So that is this one 12. Both is the intersecting point. So 12. 12 divided by true positive again. So 12 plus false negative. So false negative is nothing but model predicting something to be incorrect, but which is actually right. Here, our model is predicting these two values belongs to something as gore police and cool as ice, but which in actual is a part of rule 2. So once we add this, we'll be getting the value of sensitivity. And next is specificity. Specificity is nothing but true negative. True negative is 2317, which our model correctly predicted as belongs to something else, not rule 2. And 92 and 77. 92 and 77 because we predicted is the doesn't belongs to troll 2. So this is also comes under true negative. So once we add all these four values, we get the true negative. Next is false positive. False positive is model predicting something to be correct, but actually it is wrong. Our model is predicting 102 and 93 belongs to troll 2, but which is actually not the case. It belongs to gore police and coal. So this is about sensitivity and specificity. and how to calculate this. Thank you.